we are going to start with an interactive session. So this will require you to have ideally a laptop or a cell phone so that you can do an activity. That's going to be all about the title of this, Looking for Zebras, Distinguishing ASF from Similar Swine Diseases. So as I said, I'll do a really brief introduction before we go into that activity. And then you'll have some other sessions. You'll hear from some other great speakers. And then I'll actually come back later in the session to show you some preliminary results from the activity that you've done. And then we'll have Dr. Matt Allerson talk about some on-farm surveillance that they are doing here in Minnesota. So many of you that have been to vet school may have heard this phrase before. When you hear hoofbeats, think horses, not zebras. And so that means when you approach a case to think about the most common causes of disease and not think about those super rare things. But when we're considering something like ASF, especially in a region where it's not present, that is a zebra, that is a really rare disease. And when our goal is early detection in these free areas, how do we achieve that when we have all of these other endemic disease present that you're going to be more likely to think that that's causing what you're seeing? You know, we can think about some of the textbook clinical signs and necropsy findings. You know, these are just things that I pulled from some of the USDA materials. You know, we kind of think of that typical really high fever, systemically ill pig with hemorrhagic symptoms. But in the field, we have heard and we know that ASF presentation is actually quite diverse and doesn't always appear like that textbook. So these are just some examples that I pulled from online and from articles, from publications. So for example, in the Dominican Republic, before there had been a publication on this, we had heard that it was sort of having this range of presentations. And then they were actually able to confirm this at Plum Island experimentally, that it could vary from an acute fatal form to a mild transient disease. And this is despite 99.99% similarity between the Dominican Republic strain and the European Georgia 2007 strain. And then also just a couple quotes from some articles online from Dr. Gustavo Lopez from his experience in Russia. He saw it as a subclinical form with a slow but consistent increase in mortality. From Dr. Korns in China, he saw the mortality rise more rapidly. And from Dr. Sebulis in Lithuania, he saw it as a subacute disease spreading slowly, but really highlighting those hemorrhagic symptoms. So these are just a few highlights to demonstrate that, you know, really we're seeing these various presentations of ASF that don't fit the textbook. And so when you have that happen, you know, how do you differentiate from all of these really common diseases that we're more likely to consider first? So practically any systemic disease you could think could be a differential for ASF. And I think especially here in the US, we're concerned about PRRS, because if you have that systemically ill pig, you're probably going to think it's PRRS. So that's the challenge. How do we identify ASF as early as possible amidst all of these endemic diseases that can really copycat it? So that leads us to our activity and the goal for this afternoon, for this session. So we are going to try to estimate the association between various clinical signs and necropsy findings and ASF and PRRS. Ultimately, ideally, these can be used to help inform observational protocols. And the goal is not to diagnose PRRS or ASF, but instead to kind of standardize the approach for when samples need to be taken, and especially when do we need to involve, you know, an animal health official, or when do we suspect that this could be a foreign animal disease. And so we're going to do this through an activity called conjoint analysis. And so this is where we're getting into a bit more of the geeky part of the presentation. And I'm sharing this as well, so for the researchers in the room or others that want to do this type of technique, I'm happy to talk to you more later on this. I'm just going to try to give everyone a brief overview so you can understand this. So conjoint analysis is a survey-based technique that was developed for market research. So it's used to understand consumer preferences. So for example, let's say I have various options of smartphones. I have Apple, I have an Android phone, I have Samsung, Google. And I want to know what makes a consumer choose one instead of another. What various attributes and levels of those attributes contribute to that final decision. So we could have things like the price, the operating system, the camera resolution, but they all impact that. And here we've actually adapted this method to help us understand whether we think it would be ASF or whether we think it would be PRRS. What's the association between these clinical signs and my suspicion of this disease, or what disease do I choose to think that it's going to be? So instead of price or model of the phone, we're going to be talking about different clinical signs and necropsy findings that have all been dichotomized into being present or absent for that combination of factors. Ultimately, to try to decide that suspected disease status. And so one of the strengths of conjoint analysis is it's really useful when you are working in a field where there might not be hard data available, but you do have a lot of expertise through people's experience. So this is a more formalized way to use regression techniques to estimate coefficients for all factors from survey data. So if anybody, that seems like that could fit a project of yours, I would definitely recommend looking into this technique. So the goal here is to respond to these different scenarios with different combinations of clinical signs and necropsy findings as to whether you would suspect it being a PRRS or an ASF outbreak. And the binary responses that you give us, because they'll be yes or no questions, will serve as the data for the conjoint analysis. And then using regression techniques, so things like ordinal regression, we can identify the coefficients which can ultimately be scores for each of the factors. And you'll note that some of the signs and the necropsy findings have been simplified and or combined down. That's for two reasons. One, to make them more applicable and for on-farm use, and also to simplify them for the sake of the analysis, so we don't have hundreds of factors potentially. So I know this looks kind of crazy right now, but I will walk you through this. So this is the study design that was used for this. So we have 13 factors that we chose. These are things that might be common to both PRRS and ASF, or might be more with one than the other. So we have increased mortality. We're including sudden death in that. Anorexia, or a drop in feed consumption. Huddling or fever. Erythema or cyanosis, so red skin, blue skin. Abortion, infertility. Diarrhea, reduced motility or lethargy. Vomiting. And then we have kind of a composite variable of hemorrhagic signs, so both antemortem or postmortem. Respiratory signs, things like sneezing, coughing, dyspnea, pneumonia. Neurological signs, ataxia, convulsions, tremors, paddling, and spasms. And then finally, lymphadenopathy and splenomegaly. And you'll see that we have different scenarios lettered through A through P. So the reason why there are 16 different scenarios for this is it's all chosen by a statistical analysis. So rather than us saying, oh, we're going to just create these combinations of factors, and that's what we're going to have the participants do. Instead, you need to do these using a certain design so that later when you go to analyze them using regression, you can very accurately estimate each one of the individual effects that are included in all of these scenarios. So suffice to say, again, if anybody's interested in learning more about this, I'm happy to talk to you. There's R packages for this. SPSS, if you're familiar with that, can do this as well. And I think there's also a bunch of programs online that can do this as well. But so the scenario that I want you guys to consider is that you have a commercial swine operation, about 2,500 sows, that's located in a region where PRRS and ASF are both present in equal prevalence. And you receive a report from the farm workers specifying the presence or absence of these following clinical signs and necropsy findings. And so you're actually going to do this through a Qualtrics survey. And each page you're going to be greeted by one of the scenarios. So you'll only see one of these at a time. And the factors will either be present for that scenario, so yes, and I've highlighted it to try to make it a little easier for you to quickly see it, or no, they won't be present there. And you're going to answer 4 questions that are just yes or no questions about each of these. So first, do you think that this scenario would be consistent with ASF? Are you confident that you think it's consistent or not with ASF? Do you think that the scenario would be consistent with PRRS? Yes or no? And then finally, are you confident of whether you think that it is consistent with PRRS or not? And for those of you that might be thinking, I am not a veterinarian, I don't know that I should be answering this, don't worry, we have a couple demographic questions at the very beginning. So later on, if you're worried that, oh, I don't want to mess up the results, you won't. So I would encourage everybody just to try it out. If nothing else, you'll get to kind of see how this works, and maybe you'll use it in the future. So like I said, there'll be 16 scenarios that are in a randomized order, so you might not have the same one at the same time as the person sitting next to you. And we asked that there be no, oh, what are you putting for this one? We want it to be more of an individualized response. That's kind of one of the basis of conjoint analysis. But not to say that you can't talk at all. It doesn't have to be crickets in here, but don't poke your neighbor. So the QR code will take you to the survey, so will this link. And we have kind of scattered out small printouts of these throughout the crowd. So if you aren't able to get this up here, there should be one floating somewhere around you. And if folks, for whatever reason, can't get onto the survey, I do have a limited number of paper copies as well. So worst case scenario, we do have those. And that is all I have to present to you. The rest of this session time is just time to complete that activity. And then, like I said, after you guys submit those surveys, I will go in and analyze them and then come back later to show you some results.
Okay, so for our last presentation today, we'll get back to Dr. Schambow. She's going to show the results of the exercise that we did. Feels like way before in the day, right? So it was before coffee, and we didn't even have coffee. So she's gonna show the results of that exercise, and then Dr. Matt Allerson for Holden Farms is gonna show some ideas on how we think we are hoping that these type of approaches could be used for enhanced passive surveillance. So Rachel, Matt.
Oh, thank you. Yeah, that not having coffee, that might be a little rough. But we're gonna bear through. And so I will try to go through a little speedier just because I know we're kind of already at the end of when we were supposed to be done. But hopefully you'll still enjoy this last piece. So we are gonna go through quickly the results from the activity that you guys did. And then Dr. Allerson's gonna jump in with some more of a field perspective on observational surveillance protocols. So first thing to show you is, well, who do we have here in our group? And you'll see we have a really nice spike of the Philippines. And so for those who aren't aware, we have a wonderful delegation visiting us. So we have a good group there. And then also, I think kind of as expected, from the US, but we're kind of from everywhere, which is pretty nice. And we have a lot of experience in the swine industry. We have some folks that are newer, some folks that have been here for a long time, so pretty cool. And we have a nice spread of people. So mainly in here, we are veterinarians. So I think you could see you could answer multiples answers on this one. But most people are veterinarians. And we do have some government folks, research, and other parts of the swine industry represented as well. And about 23 people said that they had seen ASF. And about 41 said that they have seen PERS out in the field. So I think actually pretty good number of people that have seen ASF, considering, we're in the US and not a lot of people have seen it here. And I will say we had 59 responses that you'll see here. I did have a couple more trickle in afterwards. Sorry you didn't make the cut if you submitted it a little later, but you will make it later on when we reanalyze all this. So going in now into what kind of factors were associated with you suspecting that it was more likely to be ASF. Here, these are the top two scenarios, so G and C. So I think at first glance, it just kind of looks like there's a lot going on. I'll show you some preliminary regression results later, which might kind of elucidate this further. And then also the least likely to be ASF. So, and both of these are the responses that had high confidence. And so here you'll see a little less going on. I think notably, we don't have hemorrhagic signs, we don't have splenomegaly, and we do not have increased mortality. And then when we think about PERS here and see what you guys answered, this one's a little clearer off the bat. So I think this is kind of neat based on your responses. So these were separate questions, right? It's not like it was an either or. So the least likely to be ASF, you guys said PERS, or sorry, said O. And then for PERS, you guys said the most likely was O. And it really is a different type of set of clinical signs. So we have abortion, diarrhea, reduced motility, lethargy, and respiratory signs. And we see that again here in the really close following E, respiratory signs, and abortion and infertility. And then when we look at what is the least likely to be PERS, now you're starting to look more like some of those ASF answers. So we have increased mortality, hemorrhagic signs, and splenomegaly. And then I very quickly did some preliminary regression analysis on this. And again, I want to really emphasize the word preliminary here. This is just kind of the quick and dirty, You saw me typing away on my laptop up here, so take that with a huge grain of salt. But I think it's still interesting to show you for now. So these are just some odds ratios. So this is first for ASF. And so when we have the outcome of, do you think this is ASF or not, yes or no? For this part, we're kind of just setting aside the confidence. So that's something we'll look into later. The highest odds ratio was hemorrhagic signs, followed by splenomegaly and increased mortality. So things I think that we tend to think are consistent with ASF, and it's interesting to see that as you kind of saw on those other responses, it's the opposite with PERS. And so the smallest odds ratios were respiratory, diarrhea, and abortion, abortion being the most smallest. And then if we look at the same thing for PERS, here we have respiratory, abortion, and lethargy being our top factors identified, and smallest being that opposite of what we saw with ASF, increased mortality, splenomegaly, hemorrhagic signs. So when we have this kind of mix of so many different clinical signs, and obviously some things are going to be common to both diseases, but it's kind of interesting to see that, at least based on your experience, these are some trends that we're highlighting. So maybe, you know, and to say a huge thank you to everyone that did this. This was a really great exercise. But you're probably wondering, why did we do this, or what can this be used for? And so that's where we're really trying to work on these enhanced passive surveillance protocols. So trying to improve the passive approach by producers in the field and by veterinarians. So this can be things like algorithms to detect trends. So you can see that's where quantitative data would be quite useful. Specialized farm staff training. So maybe you're training your farmers and their staff to look for those hemorrhagic signs and not just, you know, kind of assume that's PERS, that maybe we need to really highlight that that could be ASF. And really the goal of all of this is to shorten the time from when ASF might get into a herd, get into a country, to when we would identify those suspect animals and take samples from them. And so just to give you kind of a really quick idea of what this could look like and what we've tried out in the Center for Animal Health and Food Safety, and then I will pass it over to Matt after this to talk more about their experience here in the US. So a couple years ago, we developed this weekly scoring tool. And so the idea being that, you know, we really should consider three components. Biosecurity, so that's kind of the initial risk of a disease entering your herd, and then syndromics and necropsy on a regular basis. So making those observations for various clinical signs and necropsy findings that could be consistent with ASF. And if you're interested more in this topic, you want to read about it, Dr. Daniela Scatino actually published this in the WOA journal. She is also, maybe here, still in the crowd, back there? Yes, Danny is over there. So she worked on a lot of these projects when she was a grad student here with us in CAF, so she's another great resource on this. You can go to the QR code, or you can look for it in the WOA journal if you want to read more.